Okay, we did 5, we didn't do 6. So 6 had 3 people who wanted to do it. Why don't we do 6? Because I think I mistakenly did 5. So we can do 6 now. So what does 6 ask? I have it on the screen. Do you see it or do I need to share it? I may need to share it. Let me see if I can. Oh, that's the wrong way to share. That's no good. That's not what I want either. Fine. Okay. Does everyone see 6?
Yes.
Wonderful. Says suppose X and Y are independent random discrete variables. Complete the following joint table and calculate the probability that Y is greater than or equal to X and determine the covariance in rho. Again, this is stuff that we did, but not recently. I don't think there was something like this on the first test. Yeah, there was no joint table. So this is sort of a tricky problem. Why? Because you're given the joint table and you're given some of its entries, but there are a lot more blanks than information. And it's asking you to complete the table. So let me just write this over again under one note so that I can do the problem. So I'm just going to write this down so I don't have to come back to it. X takes values of -1, 0, and 1. Y takes values of -1 and 1. And then 0.06 is there. 0.2 is over here. All the others are blank. And 0.5 is in the middle down below, and everything else is blank. That's part A. In part B, find the probability that Y is greater than or equal to X and determine the covariance of X and Y and rho. Okay. So let's go back to OneNote so we have some space to work. Okay, so I'm just scrolling down. And now we're looking at number 6. So 6A has this joint table. It has X here. It has Y here. The values for X are -1, 0, and +1. The values for Y are -1 and 1. And the only thing you're told is this. These are blank. These are blank. Over here, you're given this to be 0.2. This is blank. And then down here, these are blank too, except for this entry here. So, and the question is, can you complete the table? Now, by the way, you can't do it the way we did number 8, making a tree and all of that stuff, because we don't even know what X and Y represents. There's no context. You're not told what X and Y represent. So you don't have to worry about making a tree in this one because you can't even keep track of the balls because you is no mention of balls in the whole problem. So how are you supposed to do this? Well, what do you know? You know that everything inside the rectangle has to add up to 1, because all the joint probabilities have to add up to 1. And you know these are the marginals on the outside. So perhaps a good place to start might be saying, if the probability that y is -1 is 0.2, then the probability that y is +1 would have to be 0.8, because these two numbers have to add up to 1. So I'll put that in a circle because that's one step closer to completing the table than we were before. And let's see. Oh, was there any other information given there? Let's go back one time because I think I forgot something important. Yeah, there it is. Suppose X and Y are independent. I left out a word, and I knew I needed it because I can't do it without it. So we know the variables are independent. What does that mean? The definition of independence means that every value in the center of the table can be obtained by taking the product of the marginals. Okay, that's the key. If you overlook the word independent, you can't do this problem. Now let's go back to OneNote. So fortunately, I remembered it. And let's just put it above. X and Y are independent. Okay. So what it means is we can figure out this entry right here. I'll put a question mark. Also, well, that entry must be the product of the 0.5 times the 0.8 because of independence. Independence says every entry in the table is the product of its corresponding marginals. So if you multiply 0.5 by 0.8, well, 8 times 5 is 40. And if you keep track of the decimal points, it would be what, 0.4? 8 times 0.5 would be 40, and 2 points, yes. So this would be 0.4. Okay. Can you see how to get one of the next entries from this? Well, yeah, I mean, 0.5 has to be this plus this. So this has to be 0.1, right? Because this plus this is how you find the marginals. But this plus this, whatever this is, must add up to 0.2. So far, let me make sure I did it right. I think it's right. So this, yeah, so this and this add up to 0.16. And if you, so what would this have to be? It would have to be 0.4 as well. Not 0.4, point what? 0.4, sorry. Because if I add 0.04 to this, that'll give me this. Okay, so it's beginning to get done. Let's review. This one here we got by independence. These two add up to 0.5, so this had to be 0.1. This, and this add up to 0.2, so this has to be 0.04. What else? Well, by independence, whatever goes here, if you multiply it by 0.2, gives you this. So question mark times point, let's give it a name. What should we call it? It doesn't matter. Let's call it P for probability. So whatever P is, if you multiply it by 0.2, you should get 0.04, which means P is really what? 0.04 divided by 0.2, which is what? 0.2 itself. So P is 0.2. But these three numbers have to add up to 1, as do these. So this has to be 0.3. And then the rest you can get from independence. This entry has to be 0.3 times 0.8, so that has to be 0.24. And this one has to be 0.2 times 0.8, so that has to be 1/6. So piece by piece, you can put it all together, but the key is the independence. If you overlook the independence, then you're stuck. How do we know it's right? Well, if this is right, it should all add up to 1 inside. But we already checked. Let's see. That this and this and this is 0.8, and this and this and this is 0.2. So all the numbers inside do add up to 1. Okay, so we're done with what? We're done with part A. It's not hard as long as you remember what independence means. If you don't remember independence, then it's an impossible problem. Okay, what about B? This was all part A. B asks, what's the probability that Y is greater than or equal to X? Well, from the table, let's see. When is Y greater than or equal to X? If they're both -1, then this would be true. Why? Because -1 is greater than or equal to -1. And the probability of that happening is this. Is -1 is Y greater than or equal to X when you're looking at -1 and 0? Is -1 greater than or equal to 0? No. So don't count that. Is -1 greater than 1? No. So don't count this. Is 1 greater than -1? Yes. So count this. Is 1 greater than 0? Yes. So count this. Is 1 greater than or equal to 1? Yes, it's equal. So it would be all of this. So when does this occur? Whenever you're one of the 4 circled probabilities, you can add them all up, but it's easier to add up the complement. That gives you 0.14. So this must add up to 0.86. Okay, go over that again because it went by quickly. I'm just comparing the X and Y values, seeing if this property holds or not. Is -1 greater than or equal to -1? Yes, so include this probability. Is -1 greater than or equal to 0? No. So don't include it. Is -1 greater than or equal to 1? No, don't include it. Is 1 bigger than or equal to -1? Yes, include it. Is 1 greater than or equal to 0? Yes, include this probability. Is 1 greater than or equal to 1? Yes, include that. If you add up all of these, you should get 0.86. So that's the answer to this part of it. And now what's left? Find the covariance. the covariance of X and Y. But we've already done one like that today. It's the expected value of X times Y minus the expected value of X times the expected value of Y. That's how you get the covariance. That's the shortcut for the covariance. Should you know the formulas? Yes. Okay, now what? How do you find each of these? Well, maybe it's easier to find the expected value of X and expected value of Y just by using the marginal tables. So how would that look? The table for Y, for example, Y takes on the values of -1 and 1. The probability that Y takes on these values turn out to be 0.2 and 0.8. So that's dependent upon being able to do part A. But assuming you can, then how do you find the expected value? You multiply these together. Y times the probability that Y is little y. So that would be -0.2, and this would be +0.8. And the weighted average would just be the expected value of Y, which would be what? -0.6. So if you have the joint table, you can recover the marginal tables. This is the table for Y. Let me see. Did I do something right there or wrong? Oh, okay. I thought that was a square, but it was part of my arrow. So I think it's okay. Check my answer sheet again. If it doesn't agree, let me know. What about Y? Well, I just did Y. What about X? X takes what values? X takes values of -1, 0, and 1. -1, 0, and 1. What are the probabilities that they take those values? That's these probabilities here. 0.3, 0.5, and 0.2. Okay. How do you find the weighted average? Multiply the value of the variable times the probability it occurs. So it's X times the probability that X is little x, which in this case is -1 times this, which is -0.3. 0 times this is 0. 1 times this is 0.2. Add it up. The expected value of Y is what? -0.1. Okay, well, that's not Y, that's X. I may be getting tired here. Okay, so we have the expected value of X is -0.1. That would go in here. The expected value of Y is 0.6. We already did that. That would go here. So the only thing we need to figure out to be done with the covariance is the expected value of X times Y. But we've already talked about how to do that. What you can do is go through this whole table, multiplying, for example, -1 times -1 times that entry, plus -1 times 0 times this entry, plus -1 times this entry. Keep doing that for all the 6 entries in the table. Sum them up, and that'll give you the expected value. So let's do it. So if I do -1 times -1, that's just 1 times 0.06, I just get 0.06. So that's one of the terms I have to add here. I'll say 0.06 plus -1 times 0 times this is 0. So that's, I don't have to worry about that. -1 times 1 times 0.04 is -0.04. So maybe this should be a -0.04. Are we done? No, that's just the first row. 1 times -1 times this would be -0.24. What's next? 1 times 0 times this is nothing. No contributions, and 1 times 1 times, that's not really a 16. What is it, a 0.16, I think? Yeah. Remember, everything in here has to be a probability. So 1 times 1 times that is 0.16. Okay, so what do these all add up to? I don't know. The 0.16 and the 0.06 add up to 0.22. And these add up to minus 0.28, I believe. Yeah. So together, you just get what? -0.06. So that's this, -0.06. Okay, so what is the covariance? It's whatever this turns out to be. Ah, but look, it's -0.06. The two minuses here would be a plus, and 0.1 times 0.6 is positive 0.06. So it actually has a nice answer, which is 0. Cool, but how do we know that's right? Well, if you think about it a minute, these x and y are independent, right? And if the variables are independent, you don't even have to go through this calculation. The covariance of independent variables is always 0. So this is correct. But it's okay. It gives us another chance to understand how to do this calculation. But it also agrees with what we know, that when x and y are independent, the covariance is 0. Okay, was that it? Or was there more? I don't know. Let me see. Oh, rho. There was more. So what's rho? Rho is the covariance of x and y upstairs, and the product of the two standard deviations. But why even bother doing the standard deviation since we know the top is 0? Which means rho is 0 too. How are we doing? I think I'm ready to turn it back to you. Let me stop sharing. Is there anything here you want to see in more detail? If there is, I think the answer key should do it. Let me see who survived. Okay. I've got a cat here. Jacob the cat. Love it. And I've lost some people, but that's understandable.
I
Any
noticed the covariance on
uh-huh.
the answer key was 0 because, or the answer key just says it's 0 because the variables are independent. Is
Yeah.
that basically like the shortcut we could take if that
Yeah.
happens?
Yeah, that's the shortcut. If you
Okay.
if you realize that, then you save yourself all the calculation. But in this case, we sort of did it in the reverse order. We did the calculation first, got 0, and then thought twice and say, oh yeah, that makes sense because they're independent. Either way would be fine. I mean, you were asked to find the covariance or the rho, whatever it was. They're both 0. So if you actually get it through the calculation, that's fine. Or if you actually just tell me they're independent, that's fine too. Other questions? Is this helping, I hope?
Yes.
I noticed
Good.
some questions have it so that we use the binomial model,
Uh-huh.
and then parts of it would basically tell us to write it out. But would writing like the sum be okay? Or do you want us to write every individual part?
I'd have to take a look. Which problem is that you're referring to?
I have one on 7B, and then I
7B.
think there is another one.
Oh, you're an asshole.
7B or 4A.
Well, which pages are they on? Because I'm looking at. Give me one of them. Whichever one you want. 7B, is that page 5? Or no, I can bring up 5. Oh, page 5 doesn't have anything. And let's see, 7B. Oh, I see. Write down an expression that work in a group of 10 and independently 6 or more students finish their exam in this. You're right, that's a binomial problem there. Are you talking about 7B? Yeah.
Yeah.
Yeah. So you could write down, if you recognize that that's a binomial problem, you can write it down. What do you want? Write down an expression that in a group of 10, 6 or more. You could write down the table and just write down sum these things up. Or you may have even had the probability table for the binomial on this test. I don't remember. The test is what, 5 years old? But I wouldn't be surprised because we had that binomial table when we were doing the binomial. So they may have just had the table with all the numbers. So that probably was what they did. But you could do the symbols if you don't have the table, or if you do have the table, you can just add up the numbers. Hey, we got time, right? This is still Tuesday. We still have 2 more days before. So let's call it a night, unless someone has a quick one. And the good thing is, even though I may not be there to help you figure some of these out now, you do have the key. And that should at least tell you the answers. Good stuff.
Thank you, Professor.
You're very welcome. See you tomorrow. Take care. And my dog got quiet.
Good night.
Finally. Good night.
Good night,
Thank you.
Professor.